working with radicals. So we are going to start this with asking you, what is the square root of 49? And hopefully you recognize right off the bat that that is 7. However, why is it 7? Because I can rewrite 49 as a number times itself, and that gives me 49. So you're taking a square root, which means I need two matching factors. So 7 is a matching factor. I need 2 of them. And so my answer, that was lovely, becomes 7. So the square root of 49 is 7. Why? Because 7 times itself is 49. Okay, so let's try 98. Well, I need to break down 98 into, 98 is not a perfect square. So I need to break down different numbers. So what's a number that goes into 98? Well, it's even. So 2 goes into 98. So I can rewrite that as 2 times 49. And now I notice something. 49 suits my purpose because I'm looking for square roots. Okay, so I can rewrite that as this, and I'm going to change the order. Why? Because it's commutative. So I'm going to take the square root of 49 times 2, and then each factor, which are the portions of a multiplication problem, gets its own radical. So I'm going to change that to the square root of 49 times the square root of 2. Well, do I know what the square root of 49 is? I do, because I just figured it out. It's 7. So this is going to be 7. Do I know what the square root of 2 is? No, it's irrational. So that's going to stay inside the radical, because I cannot simplify that down anymore. So what is the square root of 1? The square root of 1 is 1, because 1 times itself is 1. So again, the index, which is a little number on the shelf on the outside, is implied to be 2. So I need pairs or groups of 2 in order for them to come out. So now I've got this one, which is kind of sort of irritating me, because if I look at this, well, I know the square root of 1 is 1. So maybe the square root of -1 is -1. So let's look at that for a second. What happens if I have the square root of -1 times -1? Well, let's take this out of the square root for future purposes, okay? So -1 times -1 is 1, okay? So that's not going to work. Well, what if we use just the square root of 1 as 1? Well, 1 times itself is 1. So that's not going to work. So what we're going to do is depend on what we do know and then use what we don't know. So I'm going to rewrite this as 1 times -1. Each factor gets his own radical. So 1 will go in this radical, -1 will go in this radical. Do I know what the square root of 1 is? I do. It's 1. And then we're going to use the square root of -1, and we're going to label it as I, which stands for the imaginary number. Okay, so it's the imaginary number. So I've got 1I. Well, when I simplify that, what is 1 times I? It is I. Okay, so let's use the same thing. I need to break down -49. Well, I do know that that's the same thing as 49 times -1, which means each factor can get its own radical. Do I know what the square root of 49 is? I do. It's 7. Do I know what the square root of 1 is? No, it's imaginary. So I label it as I. And so my answer for this one is 7I. So again, this is not a variable. I is a symbol that means the square root of -1. It's not going to change its value. It's not going to vary. So it's not a variable. So let's look at this one. Do I know what the square root of 98 is? I do, because I found it up here. But do I know what the square root of -98 is? So I'm going to rewrite this based on what I've learned as 49 times 2. 98 is not a perfect square. I know it's even, so I divided by 2 and happily found a perfect square. And then I've got times -1. So each factor can get his own radical. So now I have the square root of 49 is 7. The square root of 2, I can only approximate that with a decimal, so I'm going to leave it as the square root of 2. And then the square root of negative 1 is I. And notice now I've moved it out front, in front of the radical. And that is because, this is your final answer, I want to be careful of the danger. If I write 7 times the square root of 2 times I don't know if that I is under the radical with the 2 or if it's next to the radical. So to be very, very, very clear, I write it in front. So remember, order doesn't matter in multiplication. This times this times this is the same thing as this times this times this. So it just makes it more clear to write it with the I in front of the radical. So let's make it a little bit harder. I have 4 plus the square root of 25 plus 7. So I would like to do as much as I can. So I'm going to look at the numerator first. What is something I know how to do? Well, I happen to know what the square root of 25 is. The square root of 25 is 5. So I've got 4 plus 5 over 7. Well, what else do I know? I know that 4 plus 5 is 9. So I have 9 over 7, and that is already an improper fraction that is reduced, so I'm going to leave it that way. Okay? So let's try this one. I need something that I know how to do. Well, I know how to take the square root of 49. What is the square root of 49? I have a 5 minus, so I've got this part, and then 5 minus what? What's the square root of 49? It is 7, and that's going to be over 4. So what is 5 minus 7? It is negative 2 over 4. That's not reduced. And we know how to reduce that. Negative 2 over 4 is going to be negative 1/2. So I get a final answer of negative 1/2. So again, this is a different way of writing negative 1/2. These have the same value. This one just could be simplified some more. So what do we notice about this one? You should immediately notice there's a negative under your radical. So this right here tells me I'm going to be dealing with imaginary numbers. Okay, so let's do what we know how to do first. Okay, so I've got 15 minus, and I'm going to rewrite this as 25 times negative 1, and that's going to be over 10. And now I know that each factor gets his own radical. So I've got, I just ran out of room. I have 15 minus the square root of 25 times the square root of negative 1 over 10. Well, do I know what the square root of 25 is? I do. So I've got 15 minus 5i over 10. So again, the square root of 25 is 5. The square root of negative 1 is rewritten as I. And now I don't have like terms. You cannot make that 10i. So I do need to reduce. So is there a common factor on the top? I can pull a 5 out of both of those terms. So that is going to look like, pull out a 5, and that leaves me with a 3 minus I over, and I just want you to see what we're doing. I'm going to rewrite 10 as 5 times 2. And then I have any number divided by itself is 1. So this ends up getting rewritten as 3 minus I over 2. So if I was a lazy math person, I would see that 5, 15, and 10 all have a 5 in common. So I could divide out of 5. What is 15 divided by 5? 3. What is negative 5i divided by 5? Negative I. What is 10 divided by 5? It's 2. Okay, so let's do the last one. We have 12 minus, and then we have a radical. So the first thing I notice, I've got a negative under a radical, which means I'm going to be dealing with imaginary numbers. So let's do what we know first. I have a 12 minus, that's the same thing as 16 times negative 1. And all of that is over 8. Well, each factor can get his own radical. Okay, So notice the 12 minus has just stayed the same. I've just been dealing with a radical. The over 8 has stayed the same. I'm just dealing with the radical. So now I have 12 minus, do I know what the square root of 16 is? I do, it's 4. Do I know what the square root of negative 1 is? No, I do not. But I'm going to write it as the imaginary number, and that's going to be over 8. So what is something common on the top I can pull out? I can pull out a 4. So that leaves me with 3 minus I over 4 times 2. And any number divided by itself is 1, which means for a simplified answer, I get 3 minus I over 2. So these two problems had the same value. They matched at the end. But what did I notice? I noticed that they started off looking slightly different. Okay, so when this one simplifies, I get this. When this one simplifies, I get this, which means these two mean the same thing.